Okay, this section we're going to be discussing standard deviation, variance, and range. Now, range is not as large of an issue as standard deviation and variance, and these two issues tend to be areas that are very confusing for most students of descriptive statistics. So first of all, we want to talk about what are the measures of dispersion. Okay? Well, first of all, what is dispersion? Basically, how far away from the mean is the standard deviation assigned. Okay? So we have it's used to calculate how far scores are spread from the mean. So if you have a list of scores from a classroom of students, and the measure of dispersion will calculate each of those scores and how they are spread from the mean score. Now, variability is the way that we use to score in a set of data. So, and that is what we usually call variance. So how far does each score vary from the mean? Now, the range is basically how far where do the score dispersions begin and where do they end? So if your top score is 100 and your lowest score is 45, we have a range of 55. Very, very simple. Now, we're going to talk about variance. All data are described as having variance. Variance is described as the degree or amount of variability or dispersion in a set of scores. Now, here's how we calculate variance. We're going to subtract the mean for the set of data from each score. So you're going to have a list of scores, and you're going to subtract those scores from the mean, or subtract the mean from those scores. Then you're going to square the difference. Then you're going to find the sum of squares. That's the total of all the squared score differences. So all those squared scores are going to be added. And then you're going to calculate the average of that sum of all the sum of those squares. You're going to calculate the average by dividing by the total number of the scores. So really what you have is a mean of the mean. Standard deviation. Standard deviation is determined by using it's a typical unit above and below the score of 100. If you think back to that that graph that I showed you, the table where it shows all the bell curve and all the different kinds of scores, we have standard deviations on there as well. Standard deviation is only one method of calculating the difference in the variability of scores. And you have to calculate this variance before you can calculate standard deviation, which is why I went over that first. So, the standard deviation is the square of the variance. So remember when we looked at variance, I said you have to get the mean of the mean. Well, that's your variance. And so therein lies your standard deviation. So, any test score that is one standard deviation above or below the mean is considered significant because you only need a very small amount. Generally, in testing, we look at educational testing, we look at 0.95 or 0.05, which is actually the number that we're using. And if it is greater than, or rather less than 0.05, we know that there is a significant difference between that score or that student's scores and the score of the norm. So here we are, we have our scale. In a normal distribution, the standard deviations represent percentages of scores shown on this bell curve. So here we have the bell curve. Okay? It's not exactly like a bell, but it's kind of. So then we have to go back to our 68%. This is where our 0 is, right here on X. Then, say we have a score that is 1 standard deviation more. Okay, so only 1. That is not considered to be significant. Now what you need to realize is that these numbers get smaller as we go. Okay? In either direction. This is negative, this is positive. Now, so if you have 2 standard deviations, however, you're going to have a very small percentage. And those numbers, as they get smaller on your F value or your P value, which is what it now is called. We no longer call them percentages, we call them P values. And I know we have a percentage mark here, but it's actually, most of the time we just call it the P value. It's a percentage of this overall population, okay? And what we're going to look at is where does everything fall out? So if you have 2 standard deviations, basically we're looking at the MR range, or as this is an older scale, calling it MR, intellectual disability. Now if we go all the way over here, we know that we're going to be in the severe range. And at this point, we're talking about profound, okay? Now, same thing over this direction. This area, this is just high average. But when you get to the 0.2, or the negative 0.2, excuse me, we need to put that the other direction. This is not MR. This is gifted over here. I'm sorry. I just realized that I told you backwards. Okay, as you go higher, this is going to be an IQ of 130. And here we have an IQ of 140, and here we would have 160 and above, or 150 and above, or somewhere in there. Okay, so what we're looking at is very, very gifted on this side, and I apologize for getting that backwards. Back this direction at the negative 2 standard deviation, that's where we're going to be looking at the MR, or the intellectual disability range. Then here, again, I'll repeat myself, this would be the severe range, and this would be the profound. Okay? In this range right here, this is where you would find Mensa quality of IQ. Okay? So there's gifted, there's Mensa, and there's extraordinaire. So,